Welcome, GeoTrig. This is section 10-5, Trigonometry and Area. The essential question is, how can you use trigonometry to find the area of a regular polygon? Let's begin. So, we're going to use trigonometry to find the area of this regular nonagon. Nonagon has 9 sides. So, this is going to be a little different from that section, I think 10-3, where we're trying to find the area of regular polygons, because the angles don't work out. Anyways, the area, we know the formula is 1/2 times the apothem times the perimeter. Okay, well, what's our perimeter in this case? It's nonagon, and there's 10 centimeters a side, so the perimeter is going to be 90 centimeters. That's easy. Now, finding the A is going to be the tricky part here. So we got our triangle, and this triangle here has been pulled out over here. Because it's a nonagon, we know that this is 360 around here, and I have 9 triangles, so each big triangle is going to be 40 degrees, and half of that's going to be 20 degrees. So that's going to be 20 degrees, this angle. That means this one over here, if this is right angle, this is going to be 70. Well, how do we figure out A? And we're going to use our trigonometric ratios here. So I know my A. I want to find A, and I know this side's 5. I don't know this hypotenuse here, but I don't need to know that. I have these angles, these two vertices right there. So let's figure this out. I can write tangent of, let's say, tangent of angle 20 is going to be opposite over adjacent. So it's going to equal 5 over A. I can rewrite this so that A equals 5 divided by tangent of 20. So now that I know that my A equals that, I can write a new equation. My area of the nonagon is going to equal 1/2 times 90 centimeters times 5 over tangent of 20. So this is where you got to use your calculator again. So let's just pull out, no, I won't pull out a calculator, can I? No. Anyways, so if you're pulling out your calculator, it's going to be 1/2 times 90, and I wish I could show you on the screen, but you're doing it on your calculator. So 1/2 times 90 is 45. So I can write that as 45. Ugh. So 45 times 5 divided by tangent of 20, and that's going to come out to approximately, the area is going to equal 618, let's say 0.2. It's rounded to the nearest tenth, centimeters squared. So that's my area. I have to plug all those into a calculator. Tangent of 20 is not a special case, so you really just have to plug it in and have a calculator handy. And that's my area. Now, let's try to find the area of any triangle. And there's parts of this that are similar to what we saw with the law of cosines. So any triangle, so we can lay any triangle, and you can look in this shape. You have one flat side we'll call the base, and it doesn't matter which base you use on the triangle. But the area of a triangle is 1/2 times the base times height. Well, if it's not a right triangle, what is this height going to be if we don't know what this actually is? Well, we can use our trigonometric ratios, and if we cut this into 2 right triangles here, I can say the sine of angle A, that's this angle right here, is going to equal opposite H over C. So I can rewrite that as H equals C times sine of A. Alright, so if I know C equals H times sine of A, I can plug that in for this H right here, and I get a whole new formula. The area of a triangle given a side angle side equals 1/2 times B times C times sine of A. So and this all depends on your base. So your base has to be kind of the opposite of whatever angle this is. So if A is right here, we're looking at a triangle right here. So it's going to be 1/2 times the 2 sides times the sine of that angle. So you need to know 2 sides and then the interior angle, side of a triangle, to find the angle, the area of that triangle. Yeah, let's do this. So pause the video. Okay, so the area of a regular pentagon, that's 5 sides, with 4-inch side. Round your answer to the nearest square inch. Okay, so pentagon has 5 sides. I'm going to draw the shape because that'll help me. So 4 inches on the sides. So, and there's my center. And I got to find the area of this triangle, or this pentagon. So the area equals 1/2 times the apothem times the perimeter. Perimeter in this case is going to be 4 times 5. So it's going to be 20 inches. Now I got to find the A. So the A in this case, and we're going to use our trig ratio. So I'm going to draw this triangle right here. I'm going to pull that triangle out. So my A is right there. This is a right triangle, And we know this has to be half the distance. This will be 2 because it has to be half of that 4 because there's 2 and 2 on that whole side. Alright, so now I got to figure out what these angles are. Well, if this is a pentagon, all the way around the pentagon is 360. And this is being divided up into 5 triangles right here. So I'm going to say, and actually it's going to be divided up, if we saw it this way, I can think of this as dividing up into 10 triangles, really. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be 10 equal triangles. So this angle right here is going to be 360 divided by 10, or 36. So this angle is going to be 36 degrees. Alright, I don't need to know this angle, I just need this information. So I can make a trigonometric ratio. The tangent of 36 is going to equal 2 over a. So therefore, your a is going to be 2 over the tangent of 36. So I'll write my new formula, plug those in for my area. 1/2 times 2 over the tangent of 36 times p, which is 20. So those 2's cancel out. Cancel. So I'm left with 20 over the tangent of 36. And at this point, plug that into your calculator. 2 divided by the tangent of 36 is going to be approximately 27.52. And it says nearest square inch, so that's the nearest integer. So I'm going to round that up. So it's going to be 28 inches squared. So that's the area, 28 inches squared. Next one. Pause the video. Alright, area of this triangle. So I know my side, angle, side right here. I can use that formula. What is that formula again? Let's see. 1/2 BC sine of A. So the area equals 1/2 BC sine of A. Okay, so that's sine of A is going to be 48. So that's going to be sine of 48. And 1/2 times 21 times 12 times sine of 48. And again, you're going to plug that into a calculator. So I'm going to go 1/2 times 21 times 12 times sine of 48. If you plug all of that in, what you're going to get is your area equals 93.6, well, just 93.6 centimeters squared. That's close enough. And that's it.